Thanks a lot, Lance. Appreciate everybody joining us here this morning. So I think we have a real good webinar to discuss with you on how we can bring things like artificial intelligence, machine learning to your network operations environments. So in terms of just some of the agenda topics that we want to cover today, we do want to at least start off and kind of set the stage and talk about the evolution of where network management solutions are. We'll take a little bit of time, not a whole bunch of time, but really trying to grasp of, okay, where are these things going, and do they actually solve the problems that are required? And we'll also go into how analytics actually plays a key role in solving a lot of these operational issues in terms of looking at the big data, looking at vast majority of network elements and the various feeds that they can provide to help you solve that. And most importantly, how we can bring things like machine learning type of tools and applications into your environment to make that root cause analysis, from what used to be days, down to literally some type of minutes, or very very effective type of tool sets. And we'll also touch upon some different types of use cases so you can kind of see how you can use things like machine learning in your environments, some other areas that you may not even thought about going forward. So as we kind of get started, let's just talk about some of the management approaches and really the need to involve. As we look at the business challenges, so whether you're in the operations side or if you're in the planning side or even if you're on the security side, there's all these different types of challenges that you have, and you need the information to be able to decide how you most effectively you're going to resolve those issues. For example, if you're on the operations side, there's a vast majority of tools out there, but how many of those tools do you really need to either detect or troubleshoot your quality of experience type of issues? And what is the data that you actually need to use? And so, you're really about cost savings, how you can reduce some of the costs within the operations, how do you make it more effective, and increase the overall profitability of the organization that you're serving. If you're on the planning side, really looking at how can you forecast network traffic. How do you know when you're going to be in a congestion type of event down the road, or when are you going to need to add more resources to your network? Or are you downsizing even from that side? And so you need to be able to have kind of the tools, infrastructure, and typical network management systems are going to be able to provide that really effectively for them. And then on the security side, and we're talking more voice-oriented in this webinar today, but how do you know that those SIP communications are secure? So a lot of talk around stir shaking, fraud is a big problem within networks today. So how do you protect your end users, your company, corporate assets from things like telephony fraud that are happening in your network, or the nuisance calls that are happening to maybe your access customers that are out there if you're a service provider. And so you need to be able to get that type of information and be able to digest it to figure out where those problems are. So a lot of insurmountable challenges that come. And this is where your typical network management systems, your element management systems really only take you so far. So if you kind of step back, what's the goal of these network management systems? Well, it's your typical FCAPs, right? Your fault management, so that's where you're getting the alarms, monitoring of your network, certainly configuration. So we have tools here at Ribbon that, we're looking at configuration, how do we provision different types of things. You also could tie in the accounting. So if you have billing applications, you want to pull information out of your network for billing type of services. But a lot of what we see is certainly on our network management, our EMSs that we have is around the performance management. So consolidating statistics, so pulling like CPU, memory type of stats, different types of logs, data, so you have a single place to look at it. But the difference, one of the problems with that is, are you looking holistically across your entire network with these management systems, or are you just looking at individual elements? And certainly, last but not least is around the security management. But if you look at the network management systems, they're really not taking it as far as looking at toll fraud within your network. They don't have kind of the back end resources or algorithms to look at those types of situations. We're really talking about security access into the network elements themselves, and how do we provision users on the network. So if you kind of step back, these EMS type of solutions, these FCAPs, do a great job in terms of what they're aligned to, but really don't take you in terms of driving where are those problems happening within your network and how do I find them most expediently. So if you kind of even take a further step back, so you had these network management systems, probably starting like in the 1980s, and if you look at the value versus time, and if we just take the different types of technology that exist in the world that we live in real-time communications and the amount of traffic. So you can kind of start down at the bottom, it's just simple network routing. Then you bring in IPPBXs, you bring in SIP across the network for voice communications. You also have things like WebRTC, you have SMS. So the whole realm of different types of communication paths start to explode, and now you're getting into cloud communication. So network function virtualization, cloud native architectures, going into microservices. The complexity continues to go up and up and up and up. But if you look at the management tools, in relation to the technology and the different types of traffic that are coming in, they're really not keeping pace. Now, this may be a little bit of an exaggeration in terms of how they're not keeping pace, but I think the point is that your EMS systems, your OSS systems are really not tooled to be able to provide that level of deep understanding of fault isolation within your entire network. And so that's where we're trying to get to. And this is really where things like machine learning, big data analytics comes into play to help you manage those different types of situations. So you're not in a position of just not keeping pace as the technology becomes greater and greater in the amount of resources. The tools and the people don't keep pace with everything that you're providing for your network and your end customers. So this is really where we're trying to close the gap with analytics, and this is where I truly believe we have a opportunity. You have an opportunity to really understand more and more what's happening in your network. So if you think about analytics, well, it's certainly pulling in vast amount of data into the network, but how do you make it into something more actionable? So first piece is creating those KPIs, understanding what types of values to understand that network behavior. So you're correlating all of these different data points to create KPI sets that can be used to determine where problems may be occurring in your network, where you may be having congestion in the network, and how you might be able to resolve those. Are you having a quality of experience issue? Well, where is it happening? So those KPIs are exceptionally important as a starting point. You can only do that by collecting vast amount of data. And then as you kind of go down the road, you need to be able to build at least some type of rules, or create incident to be able to detect what is happening in the network. So you need that visibility to help you pinpoint any type of abnormalities. Is a particular trunk group saturated and congested? How do you know that? How do you know where to go and kind of pinpoint different types of issues? How do you know that you have a quality of service issue within a certain segment of your network? And this is really where you need to build some type of indication rule set or tools to be able to look at that network and then be able to promote any type of incident and detect those. You certainly want the dashboards, and if you look at the big knock or even SOC if you're looking on the security side, to be able to summarize that service analysis so you can kind of drill down on specific elements, be able to hone in on certain areas, look at certain time series of events that have happened and how they're all correlated together. That helps certainly in all of the troubleshooting. And obviously, with all of that, as you have incidents that come out, you want to be able to alert. And if you're very proactive, you would even set certain type of automated policies that could be triggered based on any type of incidents that are found within the network and push those back down into the underlying network. So all of this is all about, how can I use kind of, all the data in the network, be able to summarize it up in the KPIs and build out rules, but ultimately trying to improve that customer experience. That's the ultimate goal from an operations standpoint. But even though that their rules are great, and I certainly don't want to knock them, there definitely are limitations. And one is certainly around scaling. You can create hundreds, thousands of different types of rules. You can create all these across the underlying data, the systems, the organizational dimensions, however you want to set that out. And with that, becomes a lot of complexity in terms of how you're going to manage all those different types of rule sets in terms of looking for anomalies in the network. You also going to probably have to have full-time employees just to even manage the library if you start to expand those out. And are the rules are great if you're monitoring structured data, but what about if you're monitoring semi-structured or unstructured data? Well, in that case, you're just going to need more rules, and your design is going to be much more complex. The data accessibility will be challenging, and the transformation, of that data is going to be a very daunting task when you're dealing with unstructured or even semi-structured type of data. With rules, you also have fixed designs. So, you're going to be looking at specific types of measurable data. I'm going to look for a MOS score. I'm going to look for answer seizure ratio or NRE, NER type of data. So, you're really linking to, something, KPIs that are certainly measurable, being able to alert on that. So the designs are going to be very fixed, and you're not going to be able to provide necessarily a good cohesive link between various data sources. It's going to be somewhat challenging to overcome those types of inefficiencies. And then how do you calibrate? So as you're trying to build out rules, and when do you alert on certain things? So how are you going to calibrate when alerts or policies come into effect based on any type of network behaviors that you want to change? You're not going to necessarily be able to, auto-calibrate within a defined rule set. So certainly a tight kind of limitation there. And then, as we all know, well, they're very one-dimensional. So as you build a rule, you're looking for a very specific deterministic type of outcome. And that outcome is going to be based on how you design that particular rule. And so that if I'm looking for, say, bad MOS scores within the network, I'm looking for a particular value based on certain conditions, and maybe it's in certain areas of the network that I'm defining those out. So it's very one-dimensional in that, and you're probably not going to get the whole global visibility that you're expecting here. So these these three limitations, are kind of inefficient, excuse me, in terms of monitoring. And, but if you combine them with more advanced intelligent technologies that we're here to discuss today, then you get a very innovative approach that can certainly help your organizations overcome any of these types of challenges. And so I kind of like this quote. I pulled it up. I saw it out there on the internet, that rules don't expand beyond their design and have no inherent creativity. So what that means is, with a defined rule set, you're really not thinking outside the box. And this is where we want to start introducing things like machine learning, AI type of algorithms, because then you get very creative, and we'll describe a lot of that today. So ultimately, how are you going to keep pace? What are the goals that you have? Well, first, and I think everybody is well aware of this, speeding detection. You want to hasten the investigation process, enable faster response. You want to lessen the impact of any type of anomalies or attacks, especially across a distributed network. You also, want to be able to detect previously unknown vulnerabilities. So, with that kind of the rules approach, you're really looking at known vulnerabilities. But as we move into machine learning and even behavioral anomaly types of detection, we can start to alert on, what we think may be either failures within the network or any type of malicious activity, if you even take it out to the security side. You also want to be able to monitor, the activities inside your cloud network. And so you need to be able to look at, any types of, especially with the cloud and the different types of architectures, whether you're running in a microservices architecture for your communications environment or just virtualizing itself. There's a lot of different data that needs to be monitored to be able to maintain and manage those different types of cloud activities. So it's really important to be able to look at that. You also want to tie it in with speed and detection, accelerate your investigations. Where do you go? How do you, avoid downtime, the mean time to repairs? You want to avoid all of that. And ultimately, what this should all do as you are moving forward with things like analytics and how machine learning will take you forward is ultimately you want to improve your operations. So if you can provide that level of insight and provide a maximum productivity, you can start to isolate out issues, get them problem resolution out to the right folks instead of taking time to do more and more investigation. So ultimately, that's what we're here to try to convey to you today, and how we can take things like machine learning forward and help you with your operational flows. So right now, I'm going to turn it over to Chip Boyle, and he's going to start talking, how Ribbon can help enable your operations teams to be more effective with the use of AI and ML. Okay, Chip?
Yeah, thanks a lot, Walter. So maybe actually keying off of where Walter stopped, looking at Ribbon Analytics, I'm sure most of you on the call are familiar with the product, but we do have the capability of bringing in many data sources. So we look at that as being able to provide a level of visibility, right? So we want to be able to take in not just CDR data, but configuration data, PM statistics, and so forth from a number of your sources, because the networks are not single vendor. They're not actually single service and so forth. So we need that level of flexibility. I think the key is, though, ribbon analytics is really providing a foundation for agility. Walter talked quite a bit about rules-based networking management, having like a fixed one-dimensional view of what's going on. It's all within the context of we've defined network management systems to effectively manage objects, right? Manage the network elements that we understand and the attributes within there. What analytics allows us to do is actually open that up to any dimension. It's multidimensional. Because it's an analytics platform, the intent is to actually have a data pipeline. So now we've taken fixed logic and moved it into a realm of actually being able to have any data coming in, have the agility in the middle to process that data, and then create higher level apps based on that refined data so that we can improve automation. And that can be on the operations side, it can be on the security side, it can be in a number of application spaces, but you get this full view of getting the visibility, having the agility to move quickly as the data changes, and then automating those things on the back end. And a lot of what we're talking about today is really more focused on, how do we automate down to the machine learning level? So if we dig in here, obviously we're keying off of the title of this session. What are the operational problems that we can solve with machine learning? It really ends up being a lot of the things that we are doing today in network management, in element management, and so forth, where as well as even building out network element infrastructure, right? We're looking at doing things like traffic management, traffic prediction, classification, and so forth. Fault management, where understanding and isolating things, resource management, where we are in in terms of our consumption pattern, peaks and valleys, how we handle cases where we're actually overtaxing the network or the underlying equipment and handling that congestion, and how does the quality of experience actually reflect across all of these things. So these are just a few areas in terms of operational aspects that we can address with machine learning. Today we'll focus a lot more on fault management, and within there we can even break that down further into can we predict faults in the future? Can we detect existing faults, and how fast can we do that? Once we've detected that there's a fault, how do we actually localize that down to a root cause? And then eventually, how can we tie something automated on the back end of that in order to actually mitigate the problems? So if we look at things again from a data perspective, we all understand we have some core data. For voice, it really is CDRs, call detail records. That actually gives us a lot of visibility in terms of how the network is running, but it's not everything. So we can actually take that data and effectively expand it by pulling in other aspects, maybe event data or alarm data from network elements, performance statistics that are being gathered and aligned, audit trails from configurations that are going on, but even getting down into really detailed semi-structured and unstructured data such as syslogs and in debug logs. So with all of these other data sets, we can actually peel the layers of the onion beyond just having an answer that stops at a call detail record. We can associate the other data sets. We can do it in a number of ways. As Walter was saying, ribbon analytics capability gives you the ability to visualize the data, maybe on-screen stitch data sets together so you can have disparate data sets actually time aligned, and you can analyze what's going on just by kind of staring and comparing. So that's one good way, but you can lift up the hood and effectively do joins between data sets, and now actually show the relationship between CDRs and maybe underlying events that are occurring on a network element, by time, or even actually by various dimensionality. If we want to look at things from a trunk group perspective, we can align things that way. So that data blending gives you the ability to, look at the data and align it and correlate it. But in reality, doing that at the higher levels and after the fact is, can only give you so much of a view, because you may not actually have the ability to really see, did this affect the call, or did it happen in a 15-minute window along when that call was occurring? So what you eventually want to get to is a real-time, cross-correlation capability and the ability to stream in different data sources and, I like to say almost zip them together. But with these tools here on the data side, the goal really is to expose all those multiple data sources so we can dig to the root cause of what's going on. So once we have these data sets coming in, how do we actually extract insights? I think Walter went through this a bit earlier in terms of being able to build up KPIs and rules and incidents. If we want to expand that to really have an automated capability or an AI level visibility, we really need to tack models onto this. And what that modeling gives us is the ability to, I think we still need rules. You need this static set of information that allows us to stitch the data together, maybe classify the data based on, well understood aspects of how it should run. But you want to then do modeling in order to deal with the variability part of it, right? Is this a problem? In answering yes or no, is it an anomaly, or is it actually something that's baselined? Can we actually see if we're going to run off the cliff if we continue growing the network in a certain way? So the modeling aspect on the, as the last point of this data pipeline is really critical in building applications. And the Ribbon Analytics platform gives you the built-in capabilities of having applications that are just there and you can take them out of the box. When we add modeling to that, we may have to tune the models, depending on the application that's coming for a particular customer environment. But, a lot of it can come out of the box and really get you running on the, well understood data sources. But because the data sources can be broad, and even the different rules and applications and maybe even modeling goals can change, we have the ability to put together custom applications as well. So the framework, as I said before, is agile and gives the options to kind of automate in many directions, and then push that out to the consumers on the end, whether that's end users or even other automated functions that we want to tie together so that we have one well-designed workflow. Next slide, please.
Did it come over?
So if we take a lot of these, together in terms of a lot of the different problems that we can solve with machine learning, the different data sets that come in, and then building out all sorts of different models to make use of that data and gather insights, it really is, it does explode exponentially, right? We can just put a multiplication factor between each of these. But what it really is telling us is we require more automation. There's no way of getting around it. We cannot have that, a fixed FCAPs or fixed rule sets and so forth. We really need to, one, lay the foundation of analytics and having the data to be well processed so that it's ready to be analyzed, but then actually push that even further to like what applications can we put on top of that.
Hey, Chip, I missed this question, but when you were presenting on what data do we use, there was a question about, training. Do you need to train up the system based on the data sets that are coming in, or how does that work? Maybe if we can tackle that before we move forward.
Yeah. I mean, I think that the training aspect and just looking at it from a machine learning perspective, obviously there's a training and testing aspect. And normally when you create machine learning models, that early time is actually spent refining the model and making sure that it predict something or detect something with some level of confidence. So, the training question that you were asking really does depend on the data sets that are coming in and what is the ultimate goal of the function. And maybe in the next section, I'll be presenting MPC. So it's actually using predictive analytics, but the training cycle is actually built-in automated. You don't actually even expose it out to the end customer. You don't actually have to collect weeks of data and so forth. So, it really is a function of what is the application and what we're trying to do. And, you can drop it into supervised learning is something that you really do need training, and unsupervised learning is a way of like gathering insights without actually doing training. So it can range, and then you can have reinforcement training and so forth. It can range there, and I think, the great thing is the platform itself is built so that we can continue to expand and grow, in this automation journey along with our customers. So
Hey, Chip,
that was a long-winded answer. Hope I caught some of the question.
Thanks for answering that, Chip. And just a good reminder to the rest of everybody on the call, please do ask questions. If you don't see your questions box, again, you should see a question mark on the right-hand side. Click that, and you can type your question down there at the bottom right. We'd love to hear from you. So go ahead. Thanks, guys.
Yeah, good point, Lance. Thanks. Okay, so kind of moving from more of a broad perspective in terms of how we would use machine learning for network operations, we can dig into a real application. So most probable cause, if we remember back to talking about fault management and like the different aspects of fault management, we're talking about like predicting faults, detecting faults, and then like localizing a root cause. Most probable cause is intending on actually finding that root cause. And the way it's done is actually we build models for all sorts of different failure scenarios: call failures, low answer seizure rate, registration, quality of service, and so on, right? So we can build a number of models, and we use ML algorithms to effectively realize what is driving that problem with some level of confidence. And what this gives you is effectively we could tie those symptoms on the top to KPIs or other aspects of things that we're measuring in the network. And now when we're running the network, we don't have to wait for, say, hitting below 95% success rate and trigger on something. We can actually run these algorithms whenever we want and realize what's driving those problems, like big and small. So, the great part about this is I think the ellipse are there, right? It's kind of not ending. We can come up with more and more symptoms based on those data sets that I was describing before, and package those into a function. This particular application is most probable cause for voice, and we have other applications: most probable cause for VoLTE, for voice over LTE, which has a whole other set of data that's coming in and complexity associated with mobile networks. So you can kind of see the value here, and it's not even, it goes beyond voice. It really is like a generic ML function that now is part of your toolbox as a new model and capability. So if we look at MPC, most probable cause, MPC is the short for that, we could run this in a number of ways. If we're actually running in a network that's clean, then we can run MPC in the background and have it actually triggered off of an incident that might occur. So the rules that Walter was talking about, you could set up threshold crossing alarms, right? TCAs, and have a TCA actually expire. And when that hits, we can then run MPC on the data sets that are within that time window. And so this would allow us the ability to analyze reactively based on how the network is behaving, and effectively, give us a tool for dealing with outages. So we've used this actually as almost like a retrospective study. When we first were embracing on the analytics path, we had customers that had problems in their network, and traditional approaches in terms of EMS and NMS, like it would take a bit of digging, and you would have to bring in level 3 and even like maybe even engineering experts to come in to analyze what's going on. But when we brought analytics to the table, we were able to take all of that data, bring it inside, and give slicing and dicing ability. So we moved what was actually a multi-week problem into just a few days of analysis, and actually like essentially building up new dashboards on the fly, almost like as I was describing that custom application capability. We were able to use analytics to do that. Well, we then further did the retrospective study as we built MPC, the application. We then could take that same exact data and run it through the MPC algorithm, and it actually spit out the answer in seconds in terms of realizing and pointing at what is the problem gateways in the network, and the underlying attributes that are actually associated with that. So we've moved from effectively weeks to days to seconds on a real world application or outage that did occur in the network. Next slide there. So we can take MPC and use it in another way. We can use it proactively. So rather than using rules in the network to realize that there's a problem, say, a high rate of failures or so forth, we can actually run MPC and have it actually generate incidents itself. So it wouldn't be quite like a threshold crossing alarm. It's basically saying, hey, I found these problems, go look at this. So this is really more of a proactive way to analyze the network. We could run this on a continuously scheduled basis, like nightly, and in the wee hours of the night, using that extra compute time to analyze what's going on. Or we can actually use this to analyze the network for the first time to effectively scrub the network. And then from there, we can move on to being more reactive as we go forward. So another case study that we actually reviewed, we've actually done this a number of times, but we've analyzed the network in just that way, where if you think about, say, like call invites or being able to establish calls, there's a number of cause codes that are going on, and they're constantly going on, and various customers run their networks in different ways. But we can take all of that data as input in terms of all of those cause codes and analyze every single one of those as a proactive analysis. And if they meet certain criteria in terms of confidence levels and performance of the modeling and so forth, then we can expose those effectively as as new incidents that we're seeing in the network, and saying, hey, go look at this unallocated number and see what's going on there. Or we're seeing this temporary failure that's occurring, and this may be a problem that you do or don't know in the network. And by feeding these types of insights into like an incident workflow path, we now have the ability to not only actually, one, see this exposure of problems that are going on in the network, but two, actually acknowledge it and decide, okay, get a feedback from the domain experts that run the network. Oh, is this really a problem or not? And now with that feedback loop, that reinforcement learning, we can use that to tailor future runs and future outputs of what's going on. So right now, really, you can now see the power of just flipping tools around back and forth. And still a third way now, if we actually take this, again, the same pipeline that Walter was describing and that I was showing for insights, and now add predictive capabilities in the pathway, we now have a new incident detector. Right? We don't actually do it maybe based on threshold alarms or static rules. We can now actually have predictive algorithms running at this layer, say an anomaly detection, and realize that, okay, we've baselined the network and it's always running this way. We always expect that these are the time of day pattern and the day of week pattern and so forth, and this is out of scope for that, for whatever KPI. We can run across any of those. With this extra level, we now have the ability to predict that there's a problem and now run MPC on this level of insight that's occurring, or this failure scenario, and bring that up on a new dashboard. So you can see these three different ways that we're pulling together. Now you look at your performance engineers that are running your networks, and now you have this effective pipeline of work items, or trouble tickets that can come in. And not only that, but on the operational side, when you're managing the network, if there is an outage, now you have these faster tools that dig through a lot more of the data and can assist the engineers as they try to resolve problems in the network. So you can see the amount of power of just adding one tool on top of that analytics and the big data that you've brought into the system. So we do have a number of other advanced analytics solutions that are available. So in addition to MPC for voice, as I was describing before, we have MPC for voice over LTE, as well as voice over Wi-Fi for that matter. And that really covers like a mobile space and solving those problems. But we have tools that can be aligned with this, like our planner tool can be used for the traffic prediction, how is traffic growing over time. It can actually be used for any resource and managing and monitoring any resource. So you could do this to monitor your cloud resources, how much memory, how much CPU, how much storage do I have, and how is that growing over time. We can use the same algorithms themselves actually in this flip way that I was describing as anomaly detectors. Now that I know these patterns, if I see a big cave-in in the in the data that's coming in versus what I predicted it should fall into, its kind of cone of uncertainty, that actually is detecting that there is a problem. We didn't build a rule for that, but we can actually use that as a driving force to initiate, say, most probable cause as an example. On the bottom we have traffic classification. So really digging in, and again, this is going back to that slide that I was showing before, which is what can we do with machine learning? The traffic classification was one of the areas we're using this to understand fingerprints of call flows so that we can realize the patterns that our customers have in their networks, of their call subscribers. We can do this to effectively speed up testing process so we can have a faster CI/CD based agile upgrade process. If we're able to test the network faster, understand all of the call flows, mimic or simulate those call flows, that actually gives everybody the confidence level that the new software that's coming out can be deployed that much quicker. And finally, even on the media side, so I think, in some of these algorithms, it's a lot easier to actually it's a lot easier to actually analyze control plane, right? Because everything is actually built in there, right? You have cause codes that tell you that there's a problem or so forth. So the failure is there because you've actually built a protocol to deal with that. On the media side, things are a lot different. So if we're looking to get a quality of experience, we really do want to expose this level of detail so we can get the level of visibility down here, measure this, and then feed this again into these other higher level algorithms, for effectively not only giving control plane level resolutions, but even user plane level resolutions of failures in the network, whether it's MOS or maybe packet loss or so forth. So there's a lot of other areas that we're actually building out. They're not available right now, but we have a lot of brochures that can actually show you what is available and give you some details in terms of white papers, and also have the ability to engage in demos or even proof of concepts if you're interested in that. So a lot of information here and a lot to come really on the ribbon analytics side. So with that, I'll hand things back over to Lance.
Thanks, Chip. Yeah, so you see all the content there you can take on your screen. We also have a few of those sitting in the collateral area that you can take as well. So thanks for your questions. I know we addressed one sort of during the presentation. There was another one that came through, actually several more that came through. So I'll ask the first one, and then I'll let Chip, you and Walter can kind of take the lead on the others, but the first one was, can I use MPC on other data sources?
Yes. I think as I was describing before, it really is a generic algorithm. So if you can model effectively failures and successes, when we're using machine learning, this is exactly how we do it. If you can model the network in its good and bad states, then you can use the algorithm of MPC as a tool in order to analyze that and drive that to what a resolution is. I will say that the other data sources need to be somewhat rich, right? Almost like the data slide I was showing in terms of CDRs, call detail records, meaning you need to have multi-dimension available, either by, within one normalizer record like a CDR, or by doing that data blending or correlation to bring in the other levels of visibility from other sources in order to actually provide a complete picture. Because the only way I'm able to map from symptom, to cause is by having that level of blending there. So with assuming that that's there, and it is there, quite a bit in a lot of networking, we've done it in a number of these exercises, you should be able to use a lot of other data sets and engage in even other applications themselves. Okay. So yeah, maybe Walter, did you, while I was presenting, did you look at any of the other questions here?
Yeah, Lance, did you say you had a couple others? I see some.
Yeah, so the other one I have, I might have addressed this already, but can I use the ML app, the machine learning app, MPC, for detecting fraud scenarios in the network, or is it only really intended for the network faults?
Yeah, I'll cover that one. So yeah, it probably kind of keying off of what I just described before in terms of other data sources, you can look at fraud or any other application, security applications, as long as you have failures and success level of understanding, data that's kind of broken down that way, I would say labeled in a sense, then you can use this algorithm to realize that what is, is it this trunk group or this particular switch that actually we're seeing fraud coming from. Maybe it's an external one or so forth. So you're able to actually align that as well. It is definitely quite generic that way. I think the key on that side of the difficulty is ensuring that you have that good fault versus success type data viewpoint. Yeah, and we can work with folks that have an idea on that. Go ahead, Walter.
And just to expand on that even further, our analytics tie together with our call trust solution, which provides full machine learning algorithms and really a real-time focus on driving out nuisance calls, fraudulent calls from the network, give you that holistic kind of end-to-end view of preventing any type of fraudulent activities across your voice network. So as calls come in, we can provide reputation scores, back down to the SBC or PSX, depending on what you have in your network, with the call trust solution, and then gather that data and continue to make inferences and training that can be passed back up to our call trust solution via the analytics to further continue, automate and learn of what's happening in your network, so you make, the most accurate type of reputation scores based on the real-time calls that are coming in. So, combining it with call trust makes even a very powerful solution for our enterprise as well as our service provider customers in terms of combating nuisance and fraud calls.
Thanks, Walter.
Yeah.
Very good. I see another question. I'm caught up on the questions here. Do the Ribbon analytics solution support signaling and RTP media? I'm assuming this is from a data perspective. And the short answer is yes, but I'll let the product manager jump in with, if he's got a longer answer.
Well, I mean, yes, we absolutely, support the signaling and the RTP data are well, there's a couple different ways. The media capture, something that we're adding in Q4 of this year. So we have the capability. We'll have the capability to capture the media. But as Chip mentioned in one of the advanced application use scenarios, use cases, is that we have the media voice quality, and so we're taking RTP stats and feeding them into the analytics so we can get kind of a real-time measurement of the RTP from a quality of service perspective in there. And, absolutely we support the signaling and, providing, all the metrics that you would expect to see, as well as network-wide ladder diagrams so you can see hop to hop to hop of what's happening in your network to further enhance any type of troubleshooting activities.
Very good. Thanks, Walter. And then another question here. Do you have automated SIP analysis from PCAPs on SST and AS?
Yeah. So we can pull in really any PCAP, pulling in third-party PCAPs and ingest those in. So we have a mechanism, no matter what the network device is, to be able to pull those PCAPs in, ingest those, and be able to present them in our ladder diagram for different types of analysis. So all of that would be supported. And also with the application server, just to note, that's something that we're going to be adding more native integration in terms of some of the XDRs, some of the data sources also associated with that beyond just the PCAPs. And that'll be coming early next year.
Yeah, and I will add the traffic classification use case that I brought up on the advanced one is also, I believe, we import PCAPs as one of the models for doing that fingerprinting and learning of the network.
Exactly.
I think that's all of the questions here. Really good questions, though. Appreciate it.
Yeah, appreciate all that. So I guess that we're almost at the top of the hour, so that'll bring us to the end. I'm assuming this is your last slide, Walter, to show, or did you have a wrap-up of any sort?
No, this is just a thank you slide at the end. But if folks need any more information, please go out to our website. A lot of brochures. Contact your account manager. We can provide you with a more detailed demo of what we're doing around most probable cause and some of the machine learning tool sets that we have within the analytics program.
Excellent. Later this afternoon, you should be getting an email from us with a link to the replay of everything you saw today, as well as a link to the slides. So you can take a look at those at your convenience. As Walter just mentioned, ribbon.com, ribboncommunications.com. Go there. Plenty of more information, more collateral, and a million different ways to get in touch with us. You can also reply to the emails you get today if you have a question that comes up. We'll make sure it gets in the right hands. But we certainly thank you for your time today. We appreciate your questions. And again, be on the lookout for the emails later today and for the next webinars coming down the road, I'm sure, shortly. So thanks so much and have a great rest of your day. We'll see you next time.